Determine the force in each member of the space truss and state if the members are in tension or compression. The truss is supported by ball and socket joints at C, D, E, and G. Note, although this truss is indeterminate to the first degree, a solution is possible to the symmetry of geometry and holding. Because it's already given, we don't have to determine whether it's determinate or not, and we can simply start solving this structure from joint A. So let's draw the free body diagram for joint A. The joint, we're going to have our external action force 3K, and it's projecting along all the axes. Then we have our unknown force in member AB, and it's projecting only along the axis. Then we have our unknown force EA, and it's projecting along X and Y axis. And then we have unknown action force GA, also projecting along X and Y. See, one thing I forgot to mention before starting this problem, we have to understand that this structure is symmetrical. And being symmetrical, we know some of the members will be equal to each other. In this case, force in member A is going to be equal to force in angle GA, or we can say AG. Then we have force in member BE. This is going to be same as force in member BG. Similarly, force in member BC is going to be equal to force in member BD. Now back to solving our joint A. So we can start by summing the forces in y direction. You're going to have our positive y component of the 3 kilonewton, which is simply 1.5 divided by the square root of 2 squared plus, 1.5 squared plus 2 squared equals to 2.5. And then we have our y component of EA and GA, which is simply going to be negative 2 times one of the forces, either GA or EA, times their y component, which is 2 times square root of 1 squared plus 2 squared, which is equal to 2.236. All equals to 0. Solving for force EA and GA, we get our solution as 1.006 kilonewton. And because it's in positive, that means we assumed our vector test in the right direction, and our vector tells us that these two members are in tension. How we can sum the forces in z direction to find our solution for member AB. So we're going to have positive force in member AB. And then we're going to have z component of the 3 kilonewton, which is going to be negative 2 over 2.5, all equals to 0. Solving for force AB, we get our solution as 2.4 kilonewton. And because we got our solution in positive, this means this member is in compression. Now we can proceed with drawing our free body diagram for our joint B. For joint B, we're going to have an unknown force BC acting along X and Y. And so is our BD, and we're going to have our unknown force BE acting along X, Y, and Z. And then we have the opposite force BG, and finally we have unknown force AB, which is simply projecting it along the axis. Now to solve, we can start by summing the forces in z direction. We're going to have negative 2.4k. And then we're going to have positive 2 times either force PG or force PE times their z component, which is going to be 2 over square root of 2 squared plus 2 squared plus 1 squared, which is 3, equals to 0. Solving for force BE and PG, we get a solution as positive 1.8 kilonewton. And since it's positive, our vectors tell us that this member is in tension. Now we can solve the forces in y direction. Get a solution for BD and BC. We're going to have negative 2 times 1.8 kilonewton and its y component, which is simply 2 over 3. And then we're going to have positive 2 times either force BC or BD and their y component, which is 2 over 2.236, equals to 0. Solving for force BC and BD, we get our solution as 1.34